All right, are we ready to go? All right. Good afternoon, everyone. We hope you enjoyed the main ceremony, and welcome to the chemistry department program. And it's a real pleasure to welcome all of you receiving degrees and your parents and your friends and faculty and others to our graduation ceremony this year. The program you all have, I'll just say briefly what we'll do. It's written here, but I'll say just a word or two of welcome. I sort of just did that. We'll have the presentation of the student awards, our commencement speaker. Then we'll do the bachelor's degrees, the advanced degrees, and then we'll close and go have a nice lunch upstairs above us. It is actually the largest, Roger told me. There's 56 degrees, and this is the largest number I think we've had, at least in modern times. And so we have quite a few things to go through, and hopefully it'll be smooth. And with that, let's get started. And so we'll begin with a presentation of the student awards, and that's Chris Chidsey, who is head of our undergraduate studies committee. Chris.
Thank you. So I have the pleasure of making the awards today, both for the undergraduates and actually the graduate students, which is a great pleasure. So at first I'd like to recognize our two outstanding departmental peer advisors. These are undergraduates who have helped with many aspects of our program. I work closely with them, and of course Roger and other members of the undergraduate services do too. And one example of that is the prospective chemistry majors event that we hold in the autumn, and then admit weekend when students thinking about coming to Stanford come. And it's been a great pleasure to have these two individuals help me out and help out with other events of those types to recruit students to Stanford and recruit students to our department. But they also do a lot of informal work, especially with younger students in the department, and building community. And then there are three great events during the year. A fantastic Halloween party that they organize with crazy costumes for the faculty. A chemistry and popular culture trivia challenge, which demonstrates that the faculty know a lot about chemistry and very little about much else. And a t-shirt design contest. I thought about wearing my t-shirt today, but I thought the regalia was probably more appropriate. And then an end-of-year ice cream social. So in recognition of this, the chemistry department would like to reward their efforts, each of them with a $500 stipend check. And they are Bailey Schultz and Katie Welgan. You want to do it again? Have a picture. If that's the least of my screw-ups today, we'll be doing great. Okay, now we have an undergraduate award. It's the Merck Index Award to outstanding students in chemistry based on scholastic achievement in chemistry. And this year, we just had to split the award because we had two such strong academically. I'm sorry, it's the other award we're splitting. Apologize. That's a worse screw up than the last one. I'm sorry. Our strong student this year academically is Bailey John Schultz, and he will receive the Merck Index Award. All right. Now, if there hasn't been enough silliness yet, the next award is the SS and IMF Marsden Memorial Prize in Chemistry. This prize is to recognize and encourage undergraduate research in chemistry and is for an outstanding undergraduate student or students who has been involved in significant research in the chemistry department and is preferably going on in chemistry. This award comes from Professor Marsden, who was also an undergraduate at Stanford, and it is given in memory of his parents and their support for his scientific and career. And because it's called the Marsden Memorial Award, the award for it is a certificate, of course, and a $1,000 stipend, and something that Sully insisted always be, he's no longer with us, but insisted always be involved with this award, which is a bag of M&Ms to recognize the MM in Marsden Memorial. So this year's award is given to two excellent research students. The first is Michael Chen, who did his research with Professors Luo, Dieseroth, and Zaire. He pursued honors in his undergraduate education. He wrote an undergraduate thesis, which actually led to the Firestone Award this year, a very rare event in the chemistry department. We have to compete, of course, with people who write for 4 years and aren't lab rats for 4 years. And so he did a great job. It's an excellent thesis. He will continue on with research and has also been awarded a Rhodes Scholarship at Oxford, after which he will attend, he will be a PhD, MD student at Harvard and MIT. So that's our first award winner. I think I should go ahead with that first, right? And then I'll do the second one. But there was a plethora of talent this year, and so the second Marsden Memorial Award goes to Isabelle Carranza, who worked in Professor Boxer's lab, also pursued honors and wrote an undergraduate thesis. She will continue her studies as an MD PhD student at Caltech and UCLA, and we have the same award, which is this sweet. All right, and now we have an award for graduate students. This is an award in physical chemistry from the annual reviews. It's to an outstanding PhD student in physical chemistry. This year, the award goes to Chen Song for his research with Professor Martinez in a thesis entitled Advancing Ab Initio Electronic Structure Theory and Computational Methods for Excited State Molecular Dynamics. He will go on to be a postdoctoral scholar at UC Berkeley in September. The award features a free online access to the annual reviews of physical chemistry. I think Berkeley has a subscription. The Balmain Paris pen set, and of course, a certificate. And finally, we end with a really important award in the department. This is the Centennial Teaching Award, which goes to outstanding graduate students who have contributed to our educational program throughout their time here as graduate students. Now, all graduate students participate in undergraduate education and some in graduate education, but there are always a few people who stand out for their dedication to their teaching, both the quality of their teaching and their enthusiasm for participating in the program. So this year, we have 4 award winners. I'd ask them to stand and turn and face the audience. I think a few are graduating, but let me call your names. All right. So I do need to give you their names. Matthew Adronowitz is here, I believe. Yes. Carrie Betts may not be here. Oh, you are. Great. Hi, Carrie. Ben Elling. He jumped up. Yep. And Jaron Mercer. Okay, and that ends our awards for this afternoon.
Okay, thank you. And let's thank all of our award winners. Okay, so for the first of a series of degree presentations, we have 20 Bachelor of Science degrees to confer. And so let's get started. And again, oh, you're right. Thank you. All right, we just do the commencement speaker, and there I get to welcome Steve Boxer, who's going to make the introduction.
Somehow we mercifully thought we wouldn't have to listen to another talk. Well, let me just start out by, on behalf of everyone here, let me just congratulate everybody here on behalf of everyone here. So a special shout out to Isabelle and Ben, both of whom did research in my lab, and Frank and Hank, who are somewhere out there. So I know where Frank is. I'm not sure where Hank is. There's Hank. Okay. So it is my really great pleasure today to introduce Sean Decatur, who is our commencement speaker. Just a little bit of background. Sean grew up in in Cleveland. Be careful, there may be somebody from Ohio here. He got his undergraduate degree at Swarthmore College in 1990 and then came to Stanford for his PhD, which he received in 1995. I had the very good fortune to attract him into my lab, where he worked on cavity mutations in proteins and a process we call chemical rescue. Sean wanted to return to a small liberal arts college like Swarthmore, where he came from, and went immediately to Mount Holyoke College, and quickly rose through the ranks. And while he was there, it was quite a remarkable thing. He was not only an acclaimed teacher, which is, of course, the primary focus of a small liberal arts college, but he really did world-class research, working mostly with undergraduates. So really quite remarkable. The use of site-specific isotope labeling of amides and proteins, something which is now widely used by many people. I think it was already obvious, certainly to me, but also to anybody who had contact with Sean when he was a student, when he was a graduate student, that he was destined to become an academic leader. And that happened really quickly. Already at Mount Holyoke in 2001, he became chair of the chemistry department, then dean of the faculty. In 2008, he moved to be the dean of Oberlin College in his native Ohio. And in 2013, he was selected to become president of Kenyon College, and he's now really, I would say, a national leader among presidents of elite liberal arts colleges. Really a unique type of institution in the U.S. and really important. So I think at commencements you often hear, and I'm sure the students are tired of hearing how whatever they're doing now, you're being prepared for something and you don't know what it is going to be, and it's an unpredictable future. And I think that would certainly apply here. We don't all end up being or want to be university presidents, but I think it was pretty clear that Sean was destined for this role. So we really look forward to hearing his comments, and we welcome you back to the department. Sean.
Thank you, Steve, and to the faculty and to the gathered family and friends, and most importantly to the graduates that are assembled here today, good afternoon, and to the graduates, congratulations. I was doing some counting before I came and while I was preparing to come back to the department for this event, and I realized that counting my own and the graduation of my daughter, this is my 25th college or university graduation ceremony. And I turned 50 this year, and so that means at this stage in my life I've attended one commencement ceremony for every 2 years that I've been alive. Now, this illustrates a basic principle that I learned right here in this department while completing research for my PhD. And that is that, when you're preparing for a presentation, like you're preparing for a lab meeting, there can sometimes be the desperate attempt to find some sort of novel insight or deeper understanding by say, taking the ratio of two unrelated measurements in the hope that some profound magic arises from that. And this works on rare occasion, but more often than not, it produces yet a new parameter that leaves everyone scratching their heads. And this is indeed one of those moments. Now, at this stage, I remember very few details of any of those graduation ceremonies, even my own. But this one is the opportunity to address the chemistry graduates assembled here today is special to me, in part because of the honor of returning to an institution and a department that played a critical role in my own intellectual growth and development, and that fueled my passion for both science and education, and in part because of the opportunity to address chemistry graduates in particular, undergraduate and graduate. For while I've been an administrator full-time for about a decade now, my identity as a scientist and specifically a chemist has been an important part of my career. And when I reflect on what attracted me to chemistry, what ignited my interest is probably very similar to what ignited the interest of many of those here. The concept of chemical transformation and change interested me from an early age when I made my own chemistry kits from common household products, resulting in the occasional expression of frustration from my mother, which she continues to remind me of to this day, and eventually leading to her purchasing for me an official chemistry set of my own, complete with glassware separate from her dishes. In college, I was fascinated by the power of fairly simple concepts about molecular geometry, thermodynamics, and electrostatics to explain and predict complex chemical behavior. And here in graduate school, I realized that the range of problems that can be parsed and understood using these conceptual tools was not only broad, but it felt limitless. As an aside, when I first came here as a graduate student, I did rotations and spoke with faculty members, and I doubt if Steve remembers this, but we had a conversation that was about 90 minutes long that centered a lot on Scotch tape. And I still have no idea how we ended up on the topic of Scotch tape, but to a young scientist brimming with curiosity about the world, the fact that I could spend that much time talking about the chemistry of tape completely blew my mind. So overall, what drew me to chemistry was a mode of thinking, rigorous quantitative observation, the construction and application of powerful models to explain those observations, the formation of arguments and conclusions based firmly in evidence as opposed to conjecture, and creative inspirations to ask new questions or to reframe old questions. This last example was maybe the component of the thinking that excited me the most, and it still guides and informs much of my regular thinking and work. Because it's not just individual small questions that one ponders or reworks, but rather full chains of inquiry that connect large, fundamental, and at times socially impactful dilemmas, such as how do we address neurodegenerative disease, to specific questions that can be probed and tested by rigorous experimental or theoretical methods. What are the roles of specific mutations in the tau protein that impact protein aggregation? In other words, good questions fuel good thinking, and breakthroughs occur when one can see that the solutions to one set of problems provide a pathway to understanding a new and larger set of questions.
But while I was drawn to chemistry by its power as a mode of thinking and analysis, I was energized further by the way chemistry is practiced. The collaborative spirit of the laboratory, a collection of independent scientists working on specific research questions that combine to form a larger agenda, is a powerful model for working. And the positioning of chemistry at the interfaces of several fields, playing a role in addressing problems in biology, physics, materials, and the environment, among others, requires the integration of a diverse range of ideas and perspectives into any research program. I'd argue that the ability to bring together diverse groups into effective problem-solving teams and the ability to integrate ideas and concepts across a range of disciplines are two of the most important skills required for success for any career, and both are cultivated by in-depth study and research in chemistry. Now, of course, there were moments of frustration, protein samples that somehow didn't make their way into the NMR tube, but instead landed on the bench. Moments of naive cluelessness, using a flashlight to probe a photosensitive sample because I was having a hard time aligning it in the dark. I really did do that. And moments of unwarranted optimism that if I just repeated the same thing, I'd somehow eventually get the result I was expecting. Something I still find myself occasionally practicing with my students when I ask them to do an experiment over and over again. Yet these moments of sometimes spectacular failure were as essential to my learning and indeed essential to the overall process of scientific thinking. Which brings me to my current job as president of a liberal arts college. On a practical level, I use the skills practiced in the research lab here on a daily basis, especially the importance of persistent questioning, the integration of a range of perspectives on a problem, the ability to collaborate across difference, and overcoming my own frustration. But on a larger level, I see my work as president of Kenyon rooted in advocacy for the importance of liberal arts education for improving not only individual lives, but broader society. Increasingly, the liberal arts are put in opposition to studies in science, technology, engineering, and mathematics. And in fact, liberal arts is sometimes used as just a shorthand for the humanities, leaving the sciences out of the picture completely. In fact, when I became president of Kenyon, a school with a strong tradition in the liberal arts, I heard some puzzled comments on how and why a chemist would choose to lead such a liberal arts school. This despite the fact that one of our most distinguished alumni was the late Stanford chemistry faculty member, Carl Gerasi. This will not come to a surprise to any of you, especially the graduates. You are graduating from Stanford after all. But the principles of a liberal education and the modes of thinking I outlined above are nearly exactly the same. There's no opposition between the STEM fields and the liberal arts, only complementarity. Now, a quick historical review. The liberal arts derives from the Latin liberalis artis, subjects that in classical antiquity were considered essential for a free person or citizen to know in order to engage in civic life. And the courses of studies that were considered relevant included grammar, rhetoric, and logic, and eventually arithmetic, geometry, astronomy, and music. These were considered the 7 essential liberal arts disciplines of the medieval European university. And when you move into the Renaissance and modern times, the concept of the liberal arts disciplines was expanded to include the humanities, literature, arts, history, and philosophy. So in fact, the sciences were there first, is one of the arguments I often make in terms of the relationship between the STEM fields and the liberal arts. So the false equation of liberal arts with the humanities does a great disservice. Liberal arts education is incomplete without a rigorous education in the sciences, and an education in the sciences is greatly enriched by a broader context of the humanities, arts, and social sciences. The key piece to keep in mind is the purpose of learning, to generate successful citizens, and the fundamental idea that the study of these areas leads students to engage productively in civic and commercial discourse, to take on roles of leadership in society, and to be recognized as an educated person. And an education in scientific thinking is an essential piece of that. A liberal arts education is incomplete without the inclusion of rigorous scientific thinking. In fact, I would take this further, that rigorous scientific thinking is essential for citizenship in a democracy. And even further, I assert that the core concepts of scientific thinking and analysis, when applied with care and rigor, are essential to perpetuate justice in the larger world. And to probe this further, we need to take a closer look at human decision-making. Among the news stories published in 2014 was a report about a research study by MIT neuroscientists that determined that the minimal length of time required for the human mind to process information from an image is 13 milliseconds, almost an order of magnitude faster than previously believed. Now, how fast is 13 milliseconds? A blink of an eye takes 100 milliseconds. A standard camera shutter motion takes 125 milliseconds. The flap of a hummingbird wing takes about 80 milliseconds. Now, as a culture, we're somewhat obsessed with the speed of thinking and information processing. Trivia games measure one's ability to recall information quickly. Speed is still valued in primary school arithmetic and spelling drills, and we talk about innovation being driven by clock speed, the ability to process faster than competitors. Yet psychologists have also studied the facts and weaknesses in making fast judgments or in drawing quick conclusions. And the pioneering work done by Amos Tversky, the late Stanford faculty member, and Daniel Kahneman, later summarized in Kahneman's best-selling book, Thinking Fast and Slow, demonstrated that the human mind makes quick judgments by relying on heuristics that lead to cognitive biases. And as a result, we reach conclusions that are deeply flawed. We make snap judgments and assessments of probability that defy logical, reasonable conclusions from statistics, and we let bias and stereotype, especially those arising from the cultural context in which we are embedded, frame and shape our instantaneous judgments. Now, there's certainly moments when the fast-thinking systems of our brain serves us well. Our movement, whether walking, driving a car, or riding a bicycle, our ability to speak, and the ability to take direction from written signs and instructions are all governed by subconscious, near-instantaneous decision-making that is sharpened and refined by a great deal of practice and repetition. But the essence of your education, and certainly the core of the scientific thinking that you've developed, has focused primarily on your slow thinking, the ability to go deeper than the 13 millisecond observation when processing information, to expand beyond the immediate heuristic into more complex problem-solving analysis, to expand the cultural context to include information, voices, and perspectives beyond your own experience. Fast thinking helps to make us human, but slow thinking completes our humanity, expanding our capacity for creation and problem-solving. We're at a critical cultural moment when we are being pressed to believe that approaching complex problems by acting on instinct is better than rigorous preparation and analysis, or that evidence doesn't matter as much as belief in decision-making. We witness many examples where our fast thinking leads us astray and where our collective dependence on flawed instantaneous judgment results in individual and social harm, where action directed by heuristics and bias leads to perpetuation of stereotype and the reification of injustice. If we fail to approach the world around us guided by insistent questioning, if we fail to consider evidence in our judgments and decision-making, if we fail to be open to and accept ideas and concepts from different perspectives, in other words, in our everyday lives, in our work as citizens, and in our communities, if we fail to do the things that make us good chemists in the laboratory, it will be impossible to achieve a fair and just society. Now, this is not a new concept. In 1947, the 18-year-old Martin Luther King penned an essay in his college newspaper on the importance of education for the cause of justice. He said, "When we are prone to let our mental life become invaded by legions of half-truths, prejudices, and propaganda. A great majority of the so-called educated people do not think logically and scientifically. To save one from the morass of propaganda, in my opinion, is one of the chief aims of education. Education must enable one to sift and weigh evidence, to discern the true from the false, the real from the unreal, the fact from the fiction." We're all burdened by an immersion in a culture that's been shaped by legacies of deeply entrenched bias. And as a result, our fast thinking is often deeply flawed, relying upon experiences shaped by very real phenomena of racism, sexism, and other systemic ills. Lately, we have seen many examples of this. A snap judgment that a teenage boy ringing the doorbell is a potential threat worthy of a call to police and not a young person looking for help, or when one makes assumptions about character based on a person's political choice. The solution to this in part relies upon the application of slow thinking skills, rigorous scientific thinking, developed and strengthened by training. While this approach is essential for achieving a fair and just society, it's not sufficient. This is where the complementary learning from the arts and humanities comes in, developing the tools that allow us to probe the meaning of concepts like justice and develop a robust system of values. Again, I return to that essay by King, who says, "We must remember that intelligence is not enough. Intelligence plus character is the goal of true education. The complete education gives one not only the power of concentration, but worthy objectives upon which to concentrate." As an aside, this merely adds to the depressing evidence that regardless of how hard I may work, I will never quite be as insightful or articulate as the 18-year-old Martin Luther King. This definition on the purpose and power of education, the tools, has been a guide for me throughout my post-Stanford career. The tools learned in the classroom and laboratory help to make all of us better people and better citizens, combined with a robust system of values is capable not only of solving scientific problems, but truly advancing the case of equity, fairness, and justice. Slow thinking informed by evidence, driven by persistent questioning, fueled by creativity and rooted in values and ethics is the key not only to solving critical scientific problems, but also to strengthening our communities and societies. So as you move forward in your post-Stanford lives, I wish you the best and hope that the lessons from your own education will continue to sustain you and guide your decision-making and judgments in ways that move us towards a more just world, and that your own experience empowers you to be an advocate for the importance of education and educational access for all. Thank you.
All right, now, thanks again for that very wonderful and inspirational commencement address. So now we do move on to the first of the two degree awarding ceremonies, and I need some help from Chris again, and I'm going to slip behind you and go over here. And we have to come over here.
No, well. So it's my pleasure to present to you the Bachelor's Award winners, a bachelor's degree recipients of 2018. Our first recipient, Jackie Chen. Jorge Luis Chaparro. Michael Drew Chen with distinction and honors, Phi Beta Kappa, Rose Scholar, Firestone Medal winner. Layla Chu with distinction. Brian Chu with distinction, Phi Beta Kappa. Joshua James Cooper. Alejandra Felix.
Thank you.
Maxwell Freeman. Isabelle Nadine Carranza, with distinction and honors, winner of the J.E. Wallace Sterling Award for Academic Excellence and Achievement. Samuel Alejandro Jacobo. Olivia Liato. Cheyenne Ray Peltier. Thank you. Cheyenne Lealoha Poston. Nicholas Tongda Quash with distinction. Bailey John Schultz with distinction and honors Phi Beta Kappa. Benjamin David Thompson with honors. Elisa Joy Vidales. Catherine Ann Welgan with distinction, Phi Beta Kappa. And Nicolo Gabriel C. Zulebar. And that concludes the undergraduate degrees.
So I'll now welcome Ed Solomon, who is chair of the Graduate Studies Committee, to help with conferring the graduate.
We have quite a number of advanced degrees to confer, so let's get rolling. First, I'd like to confer a Master's of Science degree on Dylan Zicheng Liu. Dylan did a co-term with Dick Zare. Dylan? And I should also mention he got his undergraduate at Stanford 2 years ago in chemistry, physics, and math. Okay, so now for the PhDs. Many of our past PhDs have gone on to become international leaders in academics and in industry, and I'm very pleased to welcome the following scientists into this distinguished group. Shirley Ahn. The title of Shirley's thesis is Enhanced sampling methods for the kinetics of biomolecules, and application to triazine polymers. Oh, sorry. Heather Elise Bailey, optical Kerr effect studies for hydrogen bonding and phase behavior in aqueous binary mixtures.
All right, here we go.
Hank bought rational design of model photoactive proteins. Cyril Booker, application of enriched dihalides to the selective total synthesis of terpene natural products. Alexander James Burkle, savolysis of enantioenriched dihalides and its application to the synthesis of the brominated chamagrine sesquiterpenes. That title was competitive with Paul, actually, in the little joke we have going. Ki Min Roy Chan, novel oligodeoxyfluoroside derivatives, subnanometer fragments of graphene assembled on DNA, and a DNA-based photo switch. Spencer Andrew Clark, the development of fluorescent tools for selective labeling of biomolecules. Benjamin Ross Elling, development and applications of living, alternating ring opening metaphysis polymerization based on the single addition of substituted cyclopropenes. Ari Gold Parker, slow and fast dynamic processes in hybrid perovskite solar cell materials. Yang Ha, sulfur K-edge X-ray absorption spectroscopy and density functional theory studies on metal-sulfur covalent bonds in bioinorganic active sites.
Co-advisor here, back in the back too. And Brett, yes. Hold on. Yep. There we are. Had to get around. Let's go over there. All right, we'll make it, yes. Okay, here we go.
Matthew P. Harrigan, toward robust dynamical models of biomolecules.
Keep looking. Smile. Lots of cameras. All right, you got it. Thank you.
Olivia Lorraine Hendricks, transition metal oxide titania alloys for solar-driven water oxidation. Good. I was ready to shift. Xiaodare Xu, the analytical chemistry approach from bioorthogonal catalysis to soil organic carbon. Carmen Leal Cervantes, reactivity, you need to have the title first. Reactivity of a trans-dioxo complex towards carbon dioxide and its incorporation into a new Prussian blue framework. Huiyang Winnie Liang, investigation of the electronic structures and chemical properties of cobalt bis dioxylene valence tautomers using X-ray spectroscopies, magnetic susceptibility, and theoretical calculations. If I remember last year, Winnie didn't quite make it because she gave birth.
We got it. That was great. Okay, here.
Xinya Lo, the role of membrane curvature in nanoscale topography-induced intracellular signaling. James Booker Christensen Mack, development of metal-mediated chemoselective CH hydroxylation reactions. Timothy Michael Gale McKinsey, a conserved mechanism of voltage-gated sodium channel inactivation uncovered via synthetic batrachotoxin derivatives. Mary Ann Manampil, leveraging mixed valency for the development of electrically conductive and porous hybrid materials. skip the page. Okay. Here. Colin James McKinley, organocatalytic ring opening polymerization to access functional nanomaterials for the delivery of therapeutically relevant molecules and gene therapy targets. Jerome August McClure Mercer, synthesis of the lateran lipids. Ross Moretti, a bio-inspired manganese picolinic acid catalyst system for organic oxidations. Frank Russell Moss III, nanoscale membrane structure from lateral organization to proton permeability. Brad Andrew Polanski, modulation and detection of transglutaminase 2 activity and gluten-derived peptides in vivo, implications for celiac disease. Srinivashan Ramakrishnan, design of homogeneous transition metal hydride electrocatalyst for carbon dioxide reduction. Frederick James Seidel, catalytic and antioselective dihalogenation of allylic alcohols. Jade Shi, Bayesian approaches to building models for biological systems. The hats make it more challenging. Joseph Anthony Singh, nanomaterial design via atomic layer deposition, new methods and applications in catalysis. Chen Song, advancing ab initio electronic structure theory and computational methods for excited state molecular dynamics. Matthew Charles Stevens, the step economical supply impacting synthesis of bryostatin 1 and the development and application of rhodium catalyzed 5+2 cycloadditions of polyenes and their equivalents. Doris Ziyan Tong, synthetic studies on the bis-guanidinium toxins 11-saxitoxin ethanoic acid and zeticatoxin AB. Frederick Michael Tomlin, Chemical Approaches to the Study of N-glycanase 1, Understanding N-glycanase 1 Deficiency and Implications in Cancer Therapy. Matthias Vandenberg, passivation of the negative electrode in lithium-ion batteries, lithium fluoride, and the solid electrolyte interface. Jiang Ji, Nathan Wang, polymer semiconductors for deformable and solution processable plastic electronics. Wei Wu, investigation of novel cyclopentadienone complexes for catalytic and electrocatalytic transformations. James Jia Yan, X-ray spectroscopic studies of highly covalent iron centers, contributions to bonding and reactivity. Please join me in congratulating all our degree recipients for their singular achievement.
So that brings us to the close, or almost the close. Just like to say again, thank you all for coming, for joining us in really recognizing a very distinguished group of undergraduate and graduate degrees recipients. And thanks also to those who organized this, Roger in particular, and the staff who really managed to pull this together, and we very much appreciate superb effort in that regard. So let's thank Roger. And then just one more brief remark. I think we're privileged to have this wonderful venue, both here in the auditorium, but we're in one of the most modern centers of teaching and learning at Stanford and maybe even in the U.S. And so it's a privilege to have this facility, and it's the Sapp Center and the Sapp family who provided the donation that helped build it or renovate the old chemistry building. And so that's a real honor. It's the second time we've had the ceremony here, and we look forward to many more in the future. Two more things. There will be a lunch just up on the patio above us, and we welcome you all to come. And finally, let me ask all the graduates to stand and face the audience, and let's give them all a big hand of applause. All right, that's it, except for the undergraduates, if you could stay behind. They would like to take another picture of you with faculty. Thank you. And then find your way upstairs.